Okay, this is the second part of the video for determining Ohm's law. What we're going to do is we're going to determine the resistance across the resistance of this device here. I have here a program called Logger Pro, and it is used exclusively with Vernier sensors, which we are using for this particular experiment. I'm going to shrink this down so you can actually see what's going on. I am going to adjust this second camera so that it can see what is going on. So now so you can see here the power supply is set at 0. And so what I'm going to do is I'm going to adjust this. Here's how we're going to proceed. I'm sorry. First of all, with Ohm's law, we're going to adjust the power supply to 1 volt. Record the voltage and the current in the table, and that's going to be done by Logger Pro. We're going to continue recording data in 1 volt increments up to 5 volts and record all the data into the table. Then we're going to reverse the polarity of the voltage applied to the resistor by switching the leads at the power supply, measure current in at 3 different values of VR, and compare your previous results. And once we do that, we should get a graph, and we'll actually be able to do linear analysis with Logger Pro on this resistor. So I don't know what this resistor is, so we're going to figure it out. Okay, so switching back to the studio, let's go into experiment, data collection, and I'm not going to do time-based. I am going to do events with entry, and I'm going to call the entry name VIN, excuse me, and just make it VIN as well. In the second field, the units are volts, and that's done. So now every time I set a voltage, I am going to make a measurement. So let's go ahead and get started. So let me turn on the power supply. Let me switch my camera a little bit for 1 second so you can see what I'm doing. I am going to start the power supply up, and I'm going to have to do it this way. All right, we want to be a little careful with that. It's already set to 3 volts. We don't want that. There we go. It's now at 0. And so now I'm going to adjust the voltage knob here, and every time, or here, that's the fine adjustment, this is the coarse adjustment, and every time we do that, it's going to also record the current. So let me switch back to my camera, and we can see that the voltage and the current are 0 across the board. So let's start increasing the voltage. So I'll do a coarse adjustment, and you can see now this is reading 1.13. There's a little bit of an error there. You will not be responsible to deal with that. I will deal with that. And let's get this down a little bit more. And there we go. We're almost there. There. And I think what we're going to do is start by clicking collect. Actually, I want to do one last thing with this experiment. Data collection. I want to average over a 10-second interval because you notice that the voltage is changing rapidly over this. So I want to do a 10-second interval. So here we go. We're at 1 volt. I'm going to press keep, and it's going to take a few seconds. It's going to read the voltage. It should get us pretty close to 1.0, and there we are, and I'll call that 1.0 volts. So there we are. There's the first data point. So now the procedure is to increase the voltage in increments of 1. So I'm going to go ahead and do that. So here we go. I'm using the fine adjustment right now. and you can see that the current is changing as we go. So I'm almost there. Let's keep it at that, and I'll press to keep. So now it's going to take a little average. And there we go. This is 2 volts. Click OK. So you can see the potential is actually starting to grow, and so is the current. So now let's go to 3. And we're almost there. 3.0. I'll tap to keep that one. And it'll take about 10 seconds to run the average of what the voltage is going to be. Look at the current. The current is 0.08 amps. So this is 3 volts. Let's go ahead and get her up to 4. Click OK. There we are. I'll take her up to 3 now, or 4, sorry. And there's 4 volts. Keep this data. Take a few minutes. That's 4. And I need one more data point to satisfy things. So I'll go ahead and kick it up to 5. Look at the current. The current is about 0.13 amps right now. 7, 8, 5.1. Let's see if I can adjust that down. Okay, so here is the last data point, is 5.015. This will average out for a few minutes, and then we'll take a look at the analysis. So this is 5 volts. Click OK. And I am going to turn everything off for the moment, and just so we can do the analysis of the first part. So what I want, I'm going to get rid of this graph. This is potential versus Vn. That should be the same, and it's pretty close to it. So I'll just delete this graph. I'm going to make the second graph bigger by auto-arranging. There we are. And I'm now going to blow this up so you can see. Let's do one other thing, because typically when you take data like this, you're not going to get a smooth line like you see here. You're actually going to get a sequence of points. So I'm just going to put point symbols on here, and now you can see here's my data points for each individual voltage: 1, 2, 3, 4, and 5. So there is my 5 data points, and I'm now going to use Logger Pro to do a linear fit. So here is the linear fit, and whoops, I gotta stop it. That would help. Let's do this. I'm gonna put voltage, potential versus current. Blow it up again and do the linear fit. There we go. And what you can see, I'll just blow this up a little bit bigger for you. There. The slope of the line of voltage versus amperage is 32.95. If we look at the bands of the receiver, so just the resistor that's in the breadboard right now, let's take a look at that just to satisfy our curiosity. So I'll adjust my webcam down a little bit, and I'll take this particular lead off so we can see the colors. The colors are orange, orange, black, gold. And it's a 4-band resistor. Now there is a way of, the way that they encode it is actually readily available on the web, so I'll bring that up and I'll say resistor codes. So here it is, and let me blow this one up a little bit more so you can see it. Okay, hopefully this is big enough for you to read. So orange, orange, black, gold. Orange is 3, first band, so the first band is a 3. The second band is also a 3, so that's 33. The third band is black, that's a 0 here, so 33, 0. And the multiplier is 1, so that's black also. And the tolerance is 5%. So it's 33 ohms, and it's a 5% resistor. So what does that mean? We got, let me pull that up. We have 3295. So if we take a calculator, and I'll just bring up a garden variety calculator. Calculator. Okay, we expected 33. We got 32.95 equals 0.05 times 100. Bingo, 5%. That's a 5% resistor, 33 ohms. So we checked this out and we made this run. Now I'm going to stop this video because they're getting very large, and I am going to switch to, I'm going to do this, the back end of the experiment with another video. So I apologize for all the extra videos around, but I think it's worth it for us to have, for lack of size. Okay, thank you.